Yeah.
This one's for all you salty dogs out there.
Well, standing on the corner with the low-down blues, a great big hole in the bottom of my shoes. Honey, let me be your salty dog. Let me be your salty dog, or I won't be your man at all. Honey, let me be your salty dog. Well, down in the wild food, sitting on the log, we run through the eye of the hall. Honey, let me be your salty dog. Let me be your salty dog, or I won't be your man at all. Honey, let me be your salty dog. Well, the kids tell I know you, we're never looking at what I do. Honey, let me be your salty dog. Let me be your salty dog, or I won't be your man at all. Honey, let me be your salty dog. Well, I'm over there driving a truck. She drives so fast, she loves me so. Honey, let me be your salty dog. Well, let me be your salty dog, but I won't be your man at all. Honey, let me be your salty dog. Well, the old maid sitting in the grass, he's one finger in the other one. Honey, let me be your salty dog. Let me be your salty dog, but I won't be your man at all. Honey, let me be your salty dog. One more time. Let me be your salty dog, or I won't be your man at all. Honey, let me be your salty dog.
By the way, if anyone plays an instrument, we're gonna be holding auditions probably sometime next week. If you wanna try it.
He's our manager. He's our manager, yeah.
Where?
I don't think that's for Sarah.
Yeah. Or if you're interested, come down here and talk to one of us.
Yeah.
Conclusion. You can be happy while you are in college. If you balance things. So try to balance things so you can be happy. Instead of getting sick. You can do it. Put it in your mind and you can do it. Okay. Now let's go back to our problems. Let's do this one here. So this problem is about, as you can see, it's about this long. And it has a kind of an element of algebra there, just a very simple element of algebra. Okay? So we have two chemical equations, thermochemical equations. We have the physical state of the components of the reacting system. We have the enthalpy change right next to them, so we call them thermochemical equations. And we want to find out the enthalpy change for this chemical system. Initial state, final state. Initial state of the system, final state. We want to find for the change of this system from its initial state reactants to its final state products, how much is the enthalpy change? And you know we can manipulate, we should manipulate these two equations in such a way that by adding them we get the equation, and then accordingly we manipulate this when we make changes to this equation, and the sum of the new delta H I'm going to find, they will give me the delta H for the new for the reaction we're looking for, right? So this sometimes can be, this is not that hard. Sometimes they can be very complicated. If you have more than two, they can have 4 or 5 different equations. And you have to really manipulate them accordingly, otherwise you don't get the equation you want. So sometimes they can be very challenging. But this is not that much challenging. So what you're looking for is what you want, where do you want to go? Where do you want to go? You want to go to this. So you will not go to this unless you have one of these two equations, you have 6a. This, it has no a. This equation has a, but it has 2, and I want 6. So that tells you, you pick up the first equation, you multiply by 3. So if you do that, you will have 6a. I will not put the physical states for the sake of doing faster. Plus 3b will give you 3c plus 3d. And if I do that, now delta H is going to be different. So I'm going to put a 3 here to indicate that it's going to be different. It's not going to be the same. It's going to be equal to what? Since enthalpy is what property? Extensive or intensive property? What is it? Do you remember the difference? Yes? Energy is extensive, right? What kind of energy? All energy is extensive? Huh? There will be some energies that they are not extensive. They are, you cannot say they're extensive.
Kinetic.
Huh? What?
Kinetic.
Kinetic is what?
It's not, it's intensive.
This is, we don't have time to really go into this, but you should know extensive and intensive difference, okay? Extensive depends on the amount of the system, how big the system is, how much mass it has, the amount, the extensive. The intensive does not depend on the amount of the system, okay? So enthalpy is extensive, it depends on the amount of the system. So that's why if we multiply this by 3, we better multiply delta H by 3 also. Multiply H by 3, delta H is also multiplied by 3. Alright, so now we have 6a we want. Now we need to have 3b here. Well, we have it already. And we need to have this on the right. Okay? Well, we have d here and we have d there. We already took the first. If I want to have d here and you have not used this yet, I better use it, right? And what do I see? If I have d there, I better reverse it. Another thing that you should look is, I have a 3c here and I don't have any c here. And I have 3c there, then that can cancel out, but I have to reverse it in order to cancel out, right? So I have to reverse this, that will cancel the 3c. I don't want to be in my final equation. So by reversing the second one, I'm going to have what? 3c goes to 2d, and now delta H is going to be different. It's going to be minus of what it was before. I put a minus sign because I reversed the equation. So now if I add, this goes away with this. This 2 will give me 5d, and I have what I wanted, 6a plus 3b gives me 5d solid. And delta H, let's say 5, it's the last one, last equation, right? Delta H 5, well, it's going to be equal to the sum of these two, right? So it's going to be 3x plus 6y plus minus 4x minus 6y is equal to minus y. And then you say, therefore, delta H5 standard is minus y, x is negative, and therefore, just a little bit algebra here to use. That's going to be endo, right? Endothermic, right? Done to go to the next?